I think most people understand or and at least um, pretty well. Negation, not as well, but um, not badly. And then now we want to get to the next thing called implication, and this is the first really interesting, um, thing to study, um, really seriously, or focus on studying it in logic. So implication. So it takes two statements and outputs a single statement. And how it goes in normal everyday speaking is if you take, say, X is a dog and X is, I should choose an example that makes a little bit more sense. So X is a dog and X is an animal. Okay, take these kind of statements, and when you put them together under implication, the kind of statement you get is if X is a dog, then X is an animal. So this is starting to be one of the more complicated ways to create a logical statement. And this seems like it's a true statement, but there's no need for it to be true. It could be like X is a dog, X is a cat, and together, if X is a dog, then X is a cat. So this is just nonsense. But sometimes it'll help us understand what this does if you put in some nonsense as well. So it's important to know that, remember, like it only depends on the true and false values of the inputs, like before. So for example, if you input a true statement, okay, and you input another true statement, you'll get, so for example, you get a dog, okay. So a dog is actually an animal. So if X is a dog, so that's a true statement, then X is an animal. So that's a true statement. And so if these two statements are true, in this one instance, it should give you a true statement. And since it only depends on the true values, it'll give you a true statement in all instances. So if you just test it for dog and animal, it should work for everything. Okay, well, what if X, what if X what if X is a cat? Okay. So the second statement is true. X is a cat. But X is not a dog. So it's false for the first one. So X is not a dog. And it's a cat. So it's an animal. Okay. So, well, this is still going to be true. Okay. Just because, I mean, if you think about the first statement, if X is a dog, then X is an animal. This statement is basically true for all X. Okay, and we like sort of intuitively understand that, but we kind of we ignore. Actually, we instinctively ignore the cases when X is not a dog, because if this condition is not satisfied, this statement is almost irrelevant. But um, but irrelevant as a true state. It's still nonetheless a true statement. So if X is a dog, then X is an animal is a true statement for all animals. Okay. So, but it's just particularly meaningful for dogs. Like when it's not a dog, um, the if is not even satisfied, but the statement is still true. So that's one of the tricky things to understand about this. But again, all it depends on the true and false values, and this is a true statement all the time. Okay. But then let's have a look at when this is a false statement. So if X is a dog, then X is a cat. So this is clearly a situation where we can get a false statement. So when X is a dog, assuming we've defined cat and dog and there's not like any overlap, it cannot be a cat. So if you input a true and a false, the statement should give you a false. Because you're basically inputting a counterexample to the implication. So if X is a dog, then it's a cat. Well, you inputted something that is both a dog but not a cat. So it satisfies the if but not the then. So then therefore the statement is false. And the last one is, okay, there's only one possibility left, false and false. So when it's false and false, I want to convince you that the implication should still be true. So in the first example, so if you want to take, say, like a flower is not an animal and it's not a dog. And we're trying to say the statement, if a flower is a dog, then it is an animal. And it's true because it's not a dog, and it's so therefore it's under no obligation to be an animal. The statement is true. It might be a little bit more confusing, and for that one, you've accepted that basically the statement is true for all animals anyway. So to test it in the second statement might be a more apt test for your belief. So the second one was if X is a dog, then it's a cat. And so if you take X to be, say, a horse, it's neither a dog or a cat. Okay, that'll input two falses into the implication. And what I'm trying to tell you is that the output will still be true. So the statement that if this horse is a dog, then it's a cat is true. And it's true for the same reason that because it's a horse and it's not a dog, it was under no pressure or obligation by the statement to be a cat. And so even though the statement itself is going to be absurd, a horse will not be a value of X that will exemplify its absurdness. In fact, it'll actually still make the statement true. So the statement's really only false for whenever you input a dog, because that is the only way that you can manifestly see that the if is satisfied, it being a dog, but the then and the conclusion is not satisfied in that it's not a cat. And for everything else, it's a true statement.